and welcome to my video today. Today we're going to do some pretty cool Halloween science experiments that are fun to do at home and with some pretty common household items. So stay tuned and enjoy.
So the first Halloween science activity we're going to work with is carving a pumpkin. So get a good sized pumpkin and then you can carve it with whatever kind of face you want to carve it with. When we carved our pumpkin, this is called a physical change. It's still a pumpkin, we just changed the shapes and cut some of it out. When you carve your pumpkin, make sure that you scoop out all the seeds and all the stringy inside pieces as well. When you do that, if you want to, you can do what I did, and you can take some of the flesh from the inside of the pumpkin and you can puree it. When you puree it, you're actually blending it really, really fine, and that's another physical change. It's still pumpkin, it's just now that it's blended. You can take the seeds and you can then roast them. Here's a picture of what my seeds looked like before I roasted them. You can see they're a light color, but after I roasted them, they did change colors from the roasting into a light brown color. That is actually an example of a chemical change, because I chemically changed the pumpkin seeds and they can't be changed back.
This experiment that we're going to do next involves light sticks. So I've got 3 different colors of light sticks. 1, 2, and 3. You're also going to want hot water and cold ice water. What we're going to do today is we're going to see what kind of changes happen with a light stick and how temperature affects them. So first I'm going to take my light stick and let's go ahead and crack it. So you see that my light stick is green. When you look at the light stick, you can actually see that there's a different tube on the inside of the light stick. Whenever the inside tube and the outside tube mix when I crack it like this one, it actually has a chemical reaction because those 2 chemicals reacted together when we broke the inner tube. And now it's green. So I'm going to do it with this one. Same thing. And you can see how they react. Now I'm going to go ahead and do those with the next 2 colors while you get ready. So now we're going to see how the temperature affects our light sticks. We're going to put 1 of each color in the hot water and 1 of each color in the cold water. And we're going to let it sit there for 2 minutes and see what happens. Let's check to see what our results are. You can actually see through the cup that the hot water is clearly brighter. It's literally glowing through the cup compared to the cold water over here, which is much duller. If I pull them out and I put them on the table, you can see them that way as well. You can see there's definitely more light, more brightness from the hot. That is because the heat makes those molecules and atoms inside of the light stick move much faster, causing that chemical change to be much brighter than in the cold. For this experiment, this is called the fire snake. What we have here is some sand that's doused in some lighter fluid. We're going to put some baking soda and sugar on that, light it on fire, and see what happens.
This experiment is called a fire snake. To do this, what I did was I actually took a bowl of sand that I then doused with a lot of lighter fluid, and I also, in a separate container, mixed up about 4 tablespoons of sugar and 1 tablespoon of baking soda. I put that on top of my sand, and then I lit the lighter fluid on the sand on fire. As it lit on fire, it spread to my sugar and baking soda, which then causes this reaction where it creates a new substance, the fire snake. And if you look at the fire snake, you can see that it is totally different color. It is now a black charcoal color as it continues to rise and move and grow. This is a chemical reaction because it does have a new substance, and you can see evidence of that obviously as it grows and as the color changes. So again, make sure that anytime you're working with chemicals, even things like lighter fluid, and when you're working with fire, that you keep a safe distance and that you're being very careful if you choose to do an experiment like this. This experiment can get a little bit smelly, so again, make sure that this is something that you would want to do outside if you were doing an experiment like this. Make sure that you, again, are always safe. As you watch our rainbow fire experiment, you can see the fire is changing colors. It's changing colors as the fire interacts with different substances in the packet. So different powders are actually going to react differently to the fire. So some powders will react and turn green, some will turn blue, some might turn purple, red, and orange. And that is because it is a different chemical reaction between the two substances. Remember, when you're working with fire, you need to make sure you keep a safe distance and you're always practicing good safety techniques. Make sure that it is far away from flammable substances and that you and those around you are staying safe. In working with this specific powders, you also want to make sure that you follow the directions because some of these powders can be toxic whenever the fumes come from the fire. So make sure that you're reading all the instructions and staying safe during these kinds of experiments. Here's my oozing pumpkin experiment. For the oozing pumpkin, we are actually making a elephant toothpaste-like experiment inside of my carved pumpkin. To do that, what I did was I took about a cup of hydrogen peroxide. Then I took a cup of about 6 tablespoons of warm water and 2 tablespoons of yeast. I blended that together. I put some soap inside of my hydrogen peroxide, mixed that together, and then when I was ready, I poured the yeast and water into the hydrogen peroxide mixture. When those two interact, it does make a foam, which is our oozing pumpkin. That is a chemical change. You can actually see the new substance being created, which is that foam. There's bubbles of gas inside the foam, an exothermic heat reactions or temperature change. So you can see that this is a chemical change and a new substance. This is definitely an experiment that you want to be safe around if you ever are around it or choose to make one of these. Again, be very cautious. These are chemicals, and so you always want to make sure that you're wearing goggles and protective equipment and being safe.
So let's look at another chemical change example. Right now you see my goldenrod paper, and I'm going to spray my special potion on it and see what happens. As you can see on my special potion here, it turned red. And it turning red is an example of a color change, which is a sign of a chemical change. Something else cool that you can do with it, which you can't really see it as well, but you can sort of see some of the outline. I drew a pumpkin and wrote Happy Halloween. So how I did this experiment was I took some goldenrod paper and I wrote on it with a candle. And then obviously I sprayed my secret potion. In this case, it's an ammonia solution or Windex. And that will create the color change. Here's an example of another chemical change. Right here I have my goldenrod paper and a secret message. I'm going to reveal that secret message with my secret potion. And I'm going to spray my secret potion on it and on a paper towel to kind of wipe it on so that it doesn't overwhelm it. As you can see, my secret potion already has started to work and it's causing a chemical reaction. You can see that proof of a chemical reaction because it's turning red instead of golden. And you can see the secret message. If you wanted to do it faster, you could use the secret potion and just spray it, and that works as well. So now that I've shown you my example, let me show you how to do it. So the first step in this specific experiment is to make sure you have goldenrod paper. It has to be goldenrod paper. It can't just be colored paper. It has to be specific goldenrod paper for this to work. Then you're going to get a candle and you can write your message. So my message today was Happy Halloween, but on this one I'm going to just write boo! Exclamation point. Your secret potion is just Windex. You could also use an ammonia, mixture, which would be watered down, but I highly recommend Windex because it's much safer and it works just as well. And then just like before, if you spray it, it does turn red. Now, if you've got a super good Windex, it might cover up some of what you wrote. So be careful about that as well. But there you have it. There's our secret message. All right, for this one, we're going to do a dry ice experiment. We're going to do a couple of things with dry ice. And we're going to talk about sublimation. We're going to talk about how that relates to physical and chemical changes. So what we need for this is dry ice, soap, and water, and a few containers. So you see that I have a few containers with water in it already set up. I'm going to put some of my dry ice in some water. Now, if you're looking at the dry ice, you can see that it's instantly evaporating. That's called sublimation. That's something that's special that dry ice has, is that it goes straight from a solid to a gas. It skips the liquid stage entirely and goes straight from solid to that smoky CO2 gas that you see. If I put it in water, it happens faster. And then you get to see these beautiful little bubbles and the smokiness coming out, which is always a lot of fun, especially for Halloween like right now. Now to make it a little bit more fun, I'm going to do what I call ghost bubbles. So while I've got my ice sublimating in there, I'm going to add some soap. I'm going to do it to the big one. Watch what happens. Now, as you can see, my bubbles are coming out. They are super fun and super safe to play with. But as I pop them, you can see all that CO2 gas coming out. Super fun to play with. Highly recommend this experiment. And it's a lot of fun. If you want to add a little bit of flair to it, you can also dye it and give it some color. So I'm going to do that with this one. then you can have different colored ghost bubbles. And just enjoy watching them. Now, as you see, these things are still physical changes. Nothing really was created as a new substance. Sublimation, again, is a state of matter change, which we talked about being physical change before. And these ghost bubbles are literally just from the soap mixing with the water at a quick pace because of the dry ice. Well, there you have it. There's our dry ice experiment. Make sure if you do anything with dry ice that you're very careful. This dry ice is extraordinarily cold and can cause harm to your body. It can actually cause your skin to burn because of how cold it is. So make sure that you have good gloves or mitts. Make sure that you have something underneath it so that it doesn't damage your table. And make sure that you're very careful. If you are breaking it up, make sure you have tongs and something safe. Goggles are definitely a need while you're breaking it so that you don't accidentally hurt your eye. Thank you for joining us today, and I hope you enjoyed the experiments today for Halloween science. Make sure you like and subscribe, and we'll see you next time.